Let's have a look at the next question. 4 students, A, B, C, and D, each have a spring. They measure the length of the springs when the springs are stretched by different loads. These are the results. So for students A, B, C, and D, the spring lengths and the corresponding loads for which these lengths were measured were also given. State which student has loaded the spring beyond the limit of proportionality. We understand that the limit of proportionality is that concept where when the load is increased uniformly, the corresponding increase in the length or the extension of a spring is also uniform, or there is a linear relationship between load or force versus extension. The point beyond which the linear relationship between the load and the extension is no longer obeyed is called the limit of proportionality, also known as the elastic limit. We understand from the graph that student A and student 2 are those students who have exceeded the limit of proportionality. As we notice that beyond certain values, the linearity between the extension of the spring and the load applied are not obeyed. Explain how you obtain answer to part A. The explanation is already provided. We understand that within the limit of proportionality, the load increases uniformly, so should the extension. Whenever the extension is not uniformly increasing along with the load, or there is no linearity or a linear relationship obeyed between load and spring length, we understand that there is the limit of proportionality is exceeded. This helped us assume or answer A part 1. Moving on. For the spring used by the student A, calculate the extra extension caused by each additional 0.5 Newton. For the spring used by student A, we just have to look at the graph. We notice that for every additional 0.5 Newton of load, the additional increase in spring length is 1 centimeter. Although this is not obeyed going further right here, it is obeyed up until the limit of proportionality, which is right about till here. The unloaded length of the spring. To figure out the unloaded length of the spring, we just need to go back. We understand that the limit of proportionality is obeyed for all these load values. So if I just go back and remove the 0.5 load, I will have a spring length that would have extended by exactly 1 more centimeter. So it would have gone back to 5.7 centimeter. Student A obtains a second spring that is identical to his first spring. He hangs the two springs side by side as shown. Use the table to calculate the length of each spring when a load of 2.5 Newton is hung as shown in figure 2.2. Show your working. We understand that the student A uses two springs instead of one, and when they use two spring having an overall load of 2.5 Newton, we know that each 0.5 Newton corresponds to 1 centimeter extension in the spring. But when two springs are used instead of one, and when the same load of 0.5 Newton is used, the extension is equally divided to or equally distributed to both the spring. Now, instead of 2.5 Newton, each spring will extend by 0.5 and 0.5 centimeter. So an overall load of 2.5 Newton will cause an extension of 2.5 centimeter in each spring. So to answer, the length is 2.5 centimeter. The reason it's 2.5 and not 5 centimeter is because the load is equally distributed between both the springs. So the extension is halved for each spring.